Hi again. Here is your Professor Ed introducing the automation program. The automation program is made of 4 courses: PLC 1, PLC 2, Advanced HMI, and Integration. Actually, you will learn also about servo control and servo systems. As such, after completion of this program, made of 4 courses and based on Rockwell Automation ControlLogix 5000, you will be able to actually program and design integral machine automation, the touchscreens, the program in multi-languages, multitasking, as well as the robotics and the servo system, all integrated in one application or across the network. For this, each course will be 6 weeks, and you can connect during these 6 weeks to the virtual machine anytime you want, 24 hours a day. Also, we will have a few WebEx interface no matter where you are. In these presentations, I will help you through if you have any issues. However, the way the program is very easily to be followed, and at the end of the course, guaranteed you will have the skills that you can actually program a machine in any factory. Around the globe, Rockwell Automation is well known, is one of the most powerful software available. As such, in PLC 1, we will learn the basics. We will learn how to use the emulator 5000, how to connect to emulator 5000, how to write ladder logic, and small interfaces and HMI, simple things that are making the skills required for somebody who's working in maintenance in a shop or want to program a basic machine in the OEM, original equipment manufacturer. Second level, the course will go as an upgrade, and you will learn how to actually develop multitasking system, multitasking program that will be multi-language, ladder logic, functional block diagram, SFC, status functional charts, or structured text similar to the Visual Basic. All this will be very simple, and you will select the language according to your needs. In a functional block diagram, we will illustrate more about the process control. In ladder logic, we will continue with advanced closed loop control. In other languages, we will structure SFC for main program that will replace the old subroutines and will show where the automation is in the moment of execution. Next level will be multi-level of HMI programmed with plant packs, which is a Rockwell product that is using add-on instructions. As such, it takes the burden of development of large SCADA systems. Rockwell has all this development done for you, and you will able to actually use the power of Rockwell by learning how to program and how to set up these advanced HMI's add-on instructions. Next course will be integration, the last one. In the integration, you will actually integrate a machine. You will have to select the servo systems. You will have to select the control systems using motion analyzer and integrated architecture builder. It will be a multitask program. We will use produce consume tags from one controller to another. And also, you will have SCADA plant packs as a design base. So cutting edge technology, fast design, which give you the skills to actually be a freelancer out there and makes a lot of money. with the observation that you need to follow also the safety rules that we teach you, because the accountability of the machine safety is on you. Let's review. The first course then will teach you the basic of ladder logic and HMI. Second, PLC2, it will teach you the programmable automation controller 5000 families, all the 4 languages and multitasking, multiple HMI pages and plant packs, as well as servo system programming. The next course will be plant packs only and advanced techniques for SCADA. And the last one will be integration. To become an integrator, you will need to have your own machine designed by you. For this one, you will have a machine that is actually out there working in American Ford Glass, in many places, in Toronto, in Clearwater, Florida, Michigan, in Alberta, we have in Edmonton, Calgary. There will be a video clip of about 17 minutes with a machine made of 6 modules, multiple servo systems, and integrated hydraulic, pneumatic, and electrical precise motion. This is what's going to give you the skills as an integrator, together with the rules for the EMI, interference, and avoidance of any issues in the integration process. The requirement for the project will be that you will select servo motors based on the motion analyzer. You will select the I/O cards and the controllers based on integrated architecture builder that will give you also the sensors and everything else required. And you will write a program with SFC as a main program, and multiple programs handling multiple servo sequence and closed loop control. HMI will be designed using the plant packs, plant automation systems, and add-on instructions that are actually Rockwell products, and take your accountability to them. At the end, following the 4 courses, you will become an integrator. You will have all the skills required to claim at least 2 or more years experience in the field, because each course will be 6 weeks. You will have 6 weeks of practicing at your leisure whenever you want, connecting to a virtual machine. As an example, I decided to actually show you the first module of the basic PLC programming, and now I will start actually my program, my laptop, and I'm going to explain each component. I will use emulator 5000. So as you see here on the screen, the emulator 5000 is very similar to a SoftLogix. This SoftLogix is a software controller 5000 that converts a computer in a real controller. The first 2 cards are the connection cards. The third card is a CPU that can be installed or removed. In a rack, we can have up to 6 CPUs. We can actually put the CPU in run mode, or we can leave it in remote, as well in program mode. So we have different status for the card. Next card is an integrated input-output card that is a simulated card for the development and for testing. Next card can be another controller if you wish. We can install up to 6 controllers in the same rack. The controllers can actually communicate via produce-consume tags to each other. Now, on the other side of the screen, you can see the course material. So simply by clicking on different part of the course, you will be able to follow easily the instructions that are presented. And by looking at the instructions, we'll be able to do easily any exercise, any practicing of the ladder logic for the PLC1. There are first module is bit instructions, second module will be timers, and each one will have assignments, basic assignment like traffic lights and batch program, temperature converter, and so on. For now, I will start my programming software, that is the Studio 5000. Studio 5000 can program any member of the 5000 family, and I will start with a new program. I can call this new program First Lab, and the first lab will go on the controller that is located in slot number 2. These are the slot numbers, and by saying finish, actually the software will open in a moment with my first application that I designed for controller in slot number 2. This is the programming software, and in a moment is opening the tree of the software for programming. If I click on the main and double click on the main routine, you have the first empty rank for the program. First thing I'm going to do, I'm going to link this program to the actual controller. So I will click on the Who Active, and under the virtual backplane that is installed already in RS Links and will be described in a later presentation how to install this, we select the actual controller in slot number 2. When I click on it, you see the Set Project Path tab became active. As such, when I click on Set, now I can go and download the program. Every time I want to download, I don't need to repeat these settings, because the program knows everything I write in this program, it will sit in the controller number 2. If I want to install more controllers, simply I can, for other programs, I can right click on the empty slot, I can say controller, OK, next, I will select CPU from the motherboard, and then I say finish, and I am having the second controller in slot number 4. And then I can have another simulated I/O for this controller. Two controllers cannot own the same card. As such, you need to have separate cards for each controller and each applications. So after setting up your controller, you should minimize the controller. You cannot shut down the controller, because that's equivalent to unplugging your CPU. So I will minimize this controller for now, and I will start programming. There are many ways of doing this program. You can simply drag and drop your examine if close contact, examine if open contact, and then output energize is a bit instruction for the output card. Then I can have a branch that is like a maintaining contact for the power when I don't touch the start button. This structure is actually called auto latch. Right now, if I check the program with verification, I will have 4 errors. Each instruction has a question mark. There is no address for those input or output bits. As such, I need to put some names against these contacts. I will say this is the start button. This will be the stop button. Then output, I can say this is the coil of contactor. And simply I will click on it, right click and say new tag. New tag, it means it will go either as a base, because you have 4 types, base, alias, produce, consume. As a base will be a bit instruction in the memory of the CPU, and is Boolean type. I will locate this in the controller level. You can either have a global variable at the controller level, either you can have a local variable in the main program. Once I say create, this is actually located in the controller tags. Same for the stop, new, create. So I will go just and acknowledge all tags. By creating the last one, I can go and select it for auto latch. The coil address is an output address for an input instruction. Now I have recognized the 4 tags. So if I go in the controller tags, I have all 3 here. And if I check for errors, the ladder logic, then I will see that there is no error, 0 errors, 0 warnings. The beauty again this software I'm using, I'm connected remotely to the server, which is not here. This software is not on my machine. This is at a distance, and that's what you're going to have. You're going to have access to the remote server located in Toronto. You don't need to install anything. You will have access to everything that you see here and beyond for 6 weeks for each course. Therefore, you don't need to purchase Rockwell software. You don't need to enroll in any other program. This is the program that actually is teaching you Rockwell automation with Rockwell tools and knowledgeable professionals with many, many years of experience. For instance, myself, I programmed first time SLC 500 in 1990. So now if we want to download this program, we will go in online and we're going to say download. And with this, we say download. There is no error. It will go straight into the actual controller in slot number 2. So after finish, I say yes, and I have the controller in run mode. You can put controller in program mode or test mode, which I don't want because I want to run the program. So I leave it in run mode. Now if I want to test, I will just click on the start, toggle the bit and toggle back to simulate an instantaneous push button. What you observe is the power keep flowing through the coil, to the stop button, to the output card. Why? Because when I energize start, this is true, examine if close, yes, stop is yes, and then the coil energized, which makes the auxiliary contact to be energized. So now this rung, the power flow from the left to the right and from the top to the bottom is the way we actually execute the rungs. One important rule is that you never ever gonna duplicate outputs. The output can only be used once. Inputs doesn't matter. Again, this instruction is auto latch, is used for the main power of the machine, and the auto latch contact is an input instruction with an output address. Now I will go further with one step. I will disconnect. I can have online edit as well, but I will disconnect going offline because it's faster. I will have a second rung, and the second rung I will just put a timer. I will say this coil is on, then I want to have a timer. I can go in the timer and drag the timer, or I can double click on this rung and just write here timer on delay. Timer on delay will show up here. So timer on delay is delaying the start of something like staggering multimotors. So timer 1. On the timer 1, I can right click the tag and say, what is this? Is a timer. Where do I want it? In the controller level. Once I create this, the preset value is 0. So if I put here something like 5000, I actually have 5 seconds time delay until it's done. This bit, I will call it a done bit of this timer. So underneath, we have the preset, the accumulator register, and we have the done bit of the timer. I will put the done bit here. And the first will be the coil, which will energize when I want to energize the machine. So this will be a timer that will run to 5000. Once the accumulator is 5000, it's done. Therefore, not done bit will reset the timer to 0 and will go on and on 0, 5000, 0, 5000. If I want to use the simulated I/O card, I will click on the backplane and right click on the backplane and say new module. Under new module, I will unclick the filter and I will select others. Under others, there is a simulated I/O card. Remember, the simulated I/O card is whatever I want to use, the slot 3 or the slot 5 of the machine. I will use slot number 3, 1, 2, 3, and you need for this application to put the following numbers, 1, 2, and 16, and 210 on the other side. So 210 means twice 32 bits for the input, 32 bits for output, and 0 is just predefined. I will say OK, And now RPI, requested package interval, which is the communication between the actual CPU, is requesting a new set of data from this input card every 50 milliseconds. I will say apply and OK. Now this card is actually set and ready to be used. In order to use this card, I need to map the IOs to this card. If you take a look on the controller tags, we have all three: coil, start and stop, timer, and then from the card that I just installed, we have the local input, output, and control. Under the input, we have 32 data input and 32 data output. I will go back so you can navigate, observe, monitor, or edit tags if you want. You can populate with more tags from here by editing. It's not my best practice, but I will go back to the ladder logic and I will map the IOs. The start, I will say edit, and I will change the base in alias. Alias for what? Alias for the input, that is a local data, and will be used data 1. Under data 1, I need to select a bit. That will be bit 0. So with this one, I have set the first one, and I say apply. You see underneath local slot 3 input data 1 bit 0. Next one, I will do the same with different bits. So will be an alias for the same card, input card in slot 3, data 1, and will sit on bit number 1, apply and OK. Then the output coil, that will be an output, so will be alias for output card, local, data 0, and will be, let's say, bit 1, and apply. So I have mapped, as you observe, all the IOs, the inputs, which is start, stop, and the output, which is coil, but is used in 3 places, is used to energize an output address, which energizes the next rung that makes the timer run. This time, I cannot toggle these bits because they are having physical IO addresses. After I download, I will use the interface to actually test the program. So I will download this to the CPU in slot number 2, as I did before, because that's the link and it did not change. It's saying virtual backplane 1, slot number 2. And I am in run mode. As you observe on the left, we have energized the bar. Will execute as top to bottom, left to right. Now I am going to activate the interface. Right click on the simulated IO card, click on the properties, click on the IO data, and then bit 0, it will be the one that should start the program. Now if anything like this happen and the bit 0 doesn't want to work for the first time, we're gonna remove the card from the slot and reinstate. Reinstallment will make this work. So I remove the card. Now I have an error. If we look in the physical errors, it will say that it tried to communicate but it's failed the communication. So the program now, once I install the card again, it will definitely notice that I have a simulated card in slot number 3. So what you see here are the 32 bits from 0 to 31, which are actually the output bits. Property, IO, and then I can actually click on address 0, and there you go. You have an output 01, which is showing on the card, also is showing on here. So I can control the input bits from this interface, and I can check on the outputs. I can clear all the inputs if I want. So that's an easy way to actually play with the inputs as testing the logic. Last thing, please observe the timer. That is a timer on delay. So right now it's running, and as I said, is approaching 5,000. You cannot really see the 5,000 because of the delay introduced by a Windows operation system is going to display something like 4000 and a bit, 4700 and a bit. That was the last one, and jumping over to 100 and a bit. So is believe me, it's going to 5000, and we can monitor that if we want with another tool called Trend. I will not do that right now, but I will stop it. So I will stop the interface, and I hope you enjoyed the little ride with the 5000 Studio. That is the programming software and the easiness of programming Control Logix 5000 from Rockwell Automation. Thank you.